Welcome back, friends. Today we are going to continue with our topic of states of matter. It is somehow a long time from when I uploaded the last session regarding states of matter. And in the previous session, if you remember, we were discussing about the characteristics of the liquid which can form the ideal solution. Characteristics of a liquid which can form ideal solution. If you remember, we discussed about the nature of ideal solution, the intermolecular forces of the liquid which can form the ideal solution, and we said the intermolecular force in the pure liquids must be equal to the intermolecular forces in the mixture or in the solution. Now today we are going to continue with our topic of our states of matter, and in today's session we are going to start with the characteristics of ideal solution. As I said, in the previous session, we ended up discussing about the features or characteristics of liquids which can form ideal solution. But in today's session, we are going to discuss about ideal solution itself. Now, what are the behaviors or characteristics of ideal solution? Now, since we said in the previous session that if we have liquid A, and in the liquid A we have intermolecular forces AA, then if we have another liquid B, in the liquid B of intermolecular forces ABB, then in the solution, in the ideal solution, intermolecular forces AA, intermolecular forces AA must be equal to intermolecular forces BB, and hence we can say that intermolecular force AB will also be equal to these two types of intermolecular forces. So due to this, what we are saying is that the intermolecular force in pure liquid A is equal to intermolecular force in the pure liquid B, and hence is equal to intermolecular force in the solution. So due to the fact that the intermolecular forces in all of these three liquids, in the first and second liquid is the same, and hence the intermolecular force in the solution is the same, there will be no heat change. Why there is no heat change? Now, I know some of you have studied thermochemistry, but some of you don't know about thermochemistry. But what we are saying is that in every kind of reaction, there is bond breaking. In every kind of reaction, there is bond breaking, and also there is bond making. Now, from the concept of thermochemistry, bond breaking requires energy. It requires energy, or in short, the bond breaking reaction, it is endothermic. Bond breaking, it is endothermic reaction. So you can't break a bond until you supply energy, and this energy must be equal to the bond energy. In other words, bond-making reaction tend to supply energy, or release energy to the surrounding, and thus the reaction is exothermic. Now, what I am saying here is that when you are mixing these two liquids, that means you will break the bond between AA, and also you will break the bond between BB, and you will form the bond AB. If this bond and this bond, they have equal bond strength, with this one, that means the energy which is used to break this bond is the one which will be used, the energy which is used to break this bond is the one which will be supplied when you are making this bond. Because the process of breaking the bond between AA and BB, AA and BB, this process is endothermic. It requires energy. And then because tumesha break bond hapa, tutakuja kuform two bonds za nini? Za A, B. So kama hapa tuko tuna, let's say 2 kJ per mole, na hapa 2 kJ per mole, tukibreak this bond zote tutapata 4 kJ per mole. Formation of these two bonds between A and B will get also 4 kJ per mole. So at the end of the day, tutajikuta kwamba there is no change of heat. This is different from the non-ideal solution, is how we shall discuss later. Now we are saying that there is no change in heat, no heat released or absorbed during mixing of two solvents to form solution. So change in heat during mixing is equal to 0. The second property is that no volume change upon form ideal solution, no expansion or contraction of volume in the resulting solution. So in other words, we are saying volume A plus volume B is equal to volume of solution, That means in non-ideal solution, the property will be the same, will be different. So in other words, change in volume during mixing will be equal to 0. From there, property number 3, intermolecular force of attraction. Intermolecular force of attraction of pure solvent or liquids are equal to the intermolecular force of attraction of the solution, kama ambavyo nimesha explain hapo mwanzoni. Lakini property ya 4, any ideal solution obey Roots law. So we shall discuss in the next session what is the Roots law, and then from there we are saying that its component can be separated by fractional distillation. Simply, in the fractional distillation, it is the method of separating mixtures on basis on the boiling point. Fractional distillation. I know we studied it in Form 1, but Form 1 we shall forget. So it's the method of separation of mixtures basing on the difference in the boiling points. So we discuss this in detail in the next sessions. What is the fractional distillation and how can we separate the components of the ideal solution by fractional distillation? And another thing, what we are saying, that the boiling point of ideal solution is approximately average of the boiling points of the two liquids that form ideal solution. What do we mean by this statement? Let's say we have liquid A, and liquid A, let's say it has 100 degrees Celsius, and then liquid B, it has, let's say, 80 degrees Celsius. In the ideal solution, we will get mixture, or we'll get solution with a boiling point between 80 and 100. This is different in non-ideal solution, in which we can get boiling point of the mixture. Boiling point of the mixture in non-ideal solution can be less than 80 degrees Celsius or can be more than 100 degrees Celsius, depending on whether the non-ideal solution is of negative deviation or of positive deviation. So this is different with the property which can be seen in the ideal solution. So examples of ideal solution, we have a solution of benzene and methyl benzene, a solution of methane and water, a solution of heptane and hexane, and a solution of propan-1-ol and propan-2-ol. Propan-1-ol and propan-2-ol. All of these, they can form the ideal solution. As you can see, the molecular mass is approximately similar, and even in the structure is approximately similar. Don't forget to subscribe my channel. In the next session, we will be discussing about the Roots law and ideal solution, and then we'll discuss even some of the solved examples in the Roots law before we are moving to another part of states of matter. Thank you, everybody, and let me wish you nice studies.